Welcome everyone to Memgraph's community call. Today we have a guest joining us, Brett Brewe, and Brett is going to hold a presentation on querying Memgraph through an LLM. Just a short intro, I met Brett because he reached out to us. He had an idea of integrating Memgraph with LangChain, and I thought, and my team, that it was an awesome idea, and we teamed up a bit. He had great suggestions, and today he's going to present what he did, what he learned, and I'll let him do the intro for himself and also present everything.
Yeah, today we're going to talk about querying Memgraph through an LLM. A little bit of intro to me. My name is Brett Brewe. There's actually a guy who started MySpace who's also named Brett Brewe, but that's not me, unfortunately. I got a BS in chemical engineering from Carnegie Mellon in Pittsburgh, Pennsylvania. I leveraged that chemical engineering degree for the first 10 to 12 years of my working career, really working as a chemical engineer in the industrial process automation area. I then started work at Microsoft and had been there 25 years until I retired about 9 months ago. And I had, if you can imagine, in 25 years at a company, I did a bunch of different stuff, but I won't bore you with all of the particulars of it. As I said, I retired about 9 months ago. When I retired, obviously you want to keep the brain active. So one of the things that I did was I really started digging into AI really deeply. And so I created a bunch of chat bots. If you looked into this space, you see the phrase chat over your data quite a bit. And so that's normally chatting over some proprietary data or even an open website. And so I've done chatbots over PDFs. I did chatbot over a WordPress site that a friend of mine has to basically chat over, I would say, 10 years of blog posts that he has. I helped the author of a best-selling book do a chatbot over their book. As you can imagine, if you're an author, your publishers today are asking for supplemental content beyond the book, and creating chatbots over this kind of data is something the publishers are asking for. I would say the first sort of entry into what we're going to talk about today is I started doing some projects for doing natural language queries over SQL databases. That then sort of segued into graph databases that we'll talk about today. And I've done a bunch of other projects, both on the sort of textual side as well as photo and video. I have been primarily using OpenAI and LangChain. OpenAI, I got early access, or not early, but I got access quite quickly to the APIs. I still haven't actually gotten access to the BARD APIs, otherwise I'd be trying those as well. And then I leveraged LangChain quite a bit. If you haven't looked at LangChain, I highly recommend checking it out. Really great tools for connecting up to a whole bunch of different tools like SQL databases, graph databases, search engines, etc. And then be able to chain work across those and with LLMs. And it works with a bunch of different LLMs, not just OpenAI as well. So LangChain, if you want to get into the AI coding world, LangChain is a really great place to do it because it's a really good jumpstart. So how do we get the Memgraph? A company I advise for called Transpera. Transpera is a company for defining and viewing KPIs for your organization. They primarily focus on the industrial processes and manufacturing space, but they use Memgraph extensively in their solution. And so that kind of took me down the path of trying to do some of these same AI things for or on top of Memgraph. Note that I am not a graph database expert by any means. So this is more of me coming in from the AI perspective. When I looked at how to do this as a generalized solution, I started thinking to do it with GQL Alchemy, primarily because LangChain, its implementation on top of SQL databases uses SQL Alchemy. So I thought that was a good parallel. And I actually had done some implementations using GPL Alchemy. But then as I was in the middle of that, LangChain added a graph cipher QA chain implementation, which allows you to have the whole chain from the user entering in a natural language query, the LLM converting that into a cipher query, then querying the database to actually get the results from that cipher query, and then again querying the LLM to get taking those database results in computer speak and translating them back into natural language. And so Memgraph became an easy addition to this logic, and I'll show you how I did that. The hardest part was really the formation of schema definition. The definition, if you know Memgraph well, you know that meta-util schema is a function available to you today to get the schema of the database. But you kind of had to translate that into a format that the LLM understood. And one of the more interesting parts of the project was actually experimenting with that format to come up with a format that worked best for allowing the LLM to understand the schema of the database. And so got better at this natural language to cipher part of that chain that you're seeing. So with that, we're going to go right into the demo. I am going to use the Game of Thrones data set as part of what I'm going to be doing here today. I just use the Memgraph platform in Docker here, so everything I'm doing here, you can do the same way. But I just want to give you a quick view. This is the schema of that database. If you've watched the Game of Thrones series, you know that there are quite a lot of deaths actually in it, and so it's a lot of the schema revolves around that. And it's not a complicated database, I would say, but it has enough complexity in terms of nodes, relationships, having properties on relationships as well as nodes, that I think it'll get the point across for showing how this works. Let's see. So if I go into the code here, what you're seeing here is really just sort of the test code that I use for testing queries against that Memgraph database, in particular the Game of Thrones database. You'll see that I import in a few things from LangChain, how to integrate in with OpenAI, this graph cipher QA chain that I mentioned a few minutes ago. Prompt templates are an important part of optimizing any solution that leverages an LLM, and so we'll talk a bit more about that. And then this import, this Memgraph graph class is the class I created to do this implementation specifically for Memgraph. If we go to it, you'll notice, we create a query here that is about getting the schema. You'll notice this is a little slightly different than the meta-util schema that you might have used before, and we'll talk about what we've done there and what's coming soon for Memgraph. And then really the bulk of it is around really just getting this schema definition correct to help the LLM understand how to make correct cipher queries. And the rest of it is really just somewhat boilerplate for querying the database and initializing it. You'll note that here I subclass off a Neo4j graph, which is a class in the proper LangChain framework. And so I subclass off it and then basically just use the Neo4j drivers and the Bolt protocol to connect up to Memgraph, and that made it super simple. So if we go back to the code here, first thing you do obviously is set up a graph object that is the Memgraph connection to the database. If you've used LLMs in any way, you know that there's a series of templates you can create or text that you can create that is sort of instructions to the AI as to sort of what persona to take on and how to respond to queries and how not to respond to queries, as you can see in some of the sentences there. This first one, the cipher generation template, is the instructions to the AI in the first part of that chain, which is I'm going to give you an English natural language query convert that into a Cypher query. And then the prompt that you see there for Cypher QA, that's more about taking the Cypher results and turning that into the finalized English language version of the response from the database. And so you create some prompt templates from that. That's really just sort of LangChain ease there. And then the main part of the code really is the creation of the chain. Again, I'm just leveraging the standard graph Cypher QA chain class from LangChain. As I said, I'm using OpenAI as the LLM, and in particular GPT-4, and I'll explain why that's also important later. This is the graph object we created above. I have verbose equals true for now. As it goes through these series of chains from natural language to Cypher, et cetera, this just gives you a little bit more clues into what's happening along the way. And so I think it's important during the demo to see exactly what's happening behind the scenes. And then these are the two prompts you've seen above. I'll actually be modifying those to show you how you can make up for some errors or inefficiencies that happen as you make certain queries. So I'm going to go through this set of queries against the database. They're basically in a, from most simple to most complex order. And so in this Memgraph database class, I have a print statement here as well that'll print out the schema. I'll remove that a little later, but let's see what happens when we ask the database how many seasons there were in the Game of Thrones. You'll see the first thing that comes up is a description of the schema of the database. That would be this description here. And again, it's a variant of what is done in LangChain today for other graph databases. But through experimentation, I found that this format actually performs better. Other formats may have the word like label here instead of node name, and in other places as well. And I found, as I personally wanted to see the schema as a human and be able to have it be human readable, and also have it be more identifiable in terms of the properties and names that go with that database, I found this format to be better for me as a human in debugging this solution. And in the process found that this format of definition of the schema actually works better in producing better queries as well. And so kind of like I said in the deck, there were no best practices for how to create this schema format. This was just something you have to do through experimentation. So you'll also notice this schema gets injected here into this prompt. And so if you hear for LLMs of like, well, you're limited by the number of tokens that you get, this is really where you see this come into play. All of these text counts as tokens for what you're inputting into as the query to the data to the LLM. And so, all of this schema text that I've shown here gets injected here and counts towards that schema or counts towards that token limit. And so, as I showed, I get this directly, obviously, from querying Memgraph for the schema of the database. And that's something that, as Katerina had talked about, we worked together on, well, how do we create a version of this that makes it really easy for people who are making solutions on top of LLMs to get a schema in the best format possible to do these types of queries. If we go down here, we can say, okay, as we ask this query, we're entering a chain. It generated this cipher under the under the covers for how it would answer that question of how many seasons there are. This is the return from the database. And then this would be the final answer that you would get from the solution for the answer to your natural language query. Now, normally you wouldn't see any of this, right? Like this is mostly just for demo purposes, so you can see what's going on under the covers. What I'm going to do is actually comment out this print. So from here on out, it'll make it a little easier for us to see the output. Okay, so that was easy, right? I'm querying it. In some ways it's a bit magical, even for something as simple as that. But not that hard, right? Like that's like cipher querying 101 for really just getting a count over the number of seasons. What if we ask something slightly more complicated, like who was a particular character allied with? If you remember in the schema, characters have a relationship with allegiances. And so let's run that. We'll see it's entering a new chain. You'll see it didn't print out the schema. I still have verbose equals true, so it's going to show us the intermediate steps. This is the cipher query that was generated. You'll see that Jon Snow had two allegiances, one to House Stark, where, as you know, he grew up, and then at the Night's Watch, where he eventually ended up. And then you'll see that the LLM returns a nice English language response. And so if he didn't have verbose equals true, you'd really just get this as a response. Okay, that's nice. Also, again, a little magical, but not the most amazing complexity of the query. Let's try another one where we just say, well, what are the characters with allegiance to the White Walkers? Again, has queries, and you got a where statement here, and then you have the list of them, and then the LLM does a good job of listing these out one by one. Let's see that again. Okay, now we're getting a little more complicated. We have which characters had the most allegiances. Let's try that. Okay, here we're getting a little bit more complicated, right? And here we're getting into this sort of area where how you may query something as a cipher developer may not be exactly how a user might query it. And this, you can see the cipher query in its response. It showed all the allegiances. And along the way, what happened is you can see in the finished answer, it's only giving the answer for the ones that have two, right? So there's a small set of them that have two allegiances. The rest have one allegiance. And it did a really good job of taking that complex set of answers that came back in terms of allegiances and only giving the ones that have the most, which is what I asked for, right? So the characters will do the White Walkers. And so, I asked, find the query here again, what had the most allegiances? Typically, you would want to give some top answer or give the one with the most, right? And you can see that the LLM did that in translating this response into this response, which is really only the ones that had the most. Okay, so let's get even a little bit more complicated. And let's look at a query where not only do we want to have the, who had the most allegiances, but show them to me in a format better than what we're seeing here, which is sort of long list in English. Well, to do a little aside here, which is one thing I've learned as I've been doing a bunch of LLM projects is your first thought in doing a query like this will be, well, it's not going to know how to do that, or I'm not going to ask that question because I don't think it would be able to do it. And what I've actually sort of had to train myself to do is, no, just ask it because it'll probably work. And that's kind of one of the magical things about the LLMs is it actually can do quite a bit more than you probably have in your head right now. I was doing a different project where I was creating a whole bunch of KPIs across industries, asking the LLM for what were really good KPIs to be monitoring for certain industries. And I knew at the end of the day, I wanted to have that in a table. So I would query the LLM, and then I started to write a whole bunch of complicated parsing logic to take the output of the LLM and translate that into data structures I could put into a table, like a CSV. And then what I realized was I could just ask the CSV to return it to me as a CSV. I could just ask the LLM to return it to me directly as a CSV, and poof, I had it in the format I wanted without having to do any logic. And so as a bit of an aside, but I encourage you as you work with LLMs, try the things that you're reluctant to do because you think it might not do it. I would say 8, 9, 10 times out of 10, it'll actually do the thing you want to do. So with that aside, let's do this. One thing you'll notice in this query, it's actually the same results that you're seeing here in terms of what were the allegiances. It's actually getting a bit more information because I said, who they were. So now you need the character as well as the set of allegiances to put in the table. You notice this takes longer, right? Because the LLM is actually working on this data to do a more complicated output, which is the characters in a table with their allegiances. So now you can see you've got a fairly nicely formatted table. Not actually sure why it didn't move these end markers to be equivalent, but okay. But that's a much nicer format for the LLM that comes out. And so again, if you want it in a format for your solution or visually, I would say just ask for it from the LLM. And it'll probably do it, and it'll save you a lot of other coding time to try and translate formats. Let's ask something a little bit more complicated. I'm asking this question. You'll notice the database has locations, but I don't use location here. I just said where, and die is a different form of death, and so the LLM really has to do some work here to figure out, well, how do I translate this into a cipher query using the nodes and relationships that we have on hand in the schema. And you'll see it does this very well, creates that particular cipher query, and then returns that Jon Snow died at Castle Black. Okay, so a little bit more complicated. Let's try this one. Which episode had the most deaths of characters allied with the House of Targaryen? Okay, so this is probably the most complicated one to date in terms of cipher query. This is probably the most complicated one in terms of what we're asking the LLM to do in terms of formatting the end results. But this is the most complicated so far in terms of what we're asking from natural language to cipher generation. So let's try that. Okay, so you can see, it's somewhat complicated cipher to be able to say an episode that had the most deaths of characters, but not just characters, it's those characters that were allied with the House Targaryen. And it just had to be an episode called The Sons of the Heart. You could even tack on to here, in the comma, and what were they, right? So let's try that. So let's try this. We'll do it with House Stark. I think I have here. but let's ask the same kind of thing, but I actually want to know who the characters were as well. So this is basically the most complex one. So it's a little bigger so you can see the cipher that happened. And then the LLM, I think, does a pretty good job where it returns a nice English language response to this query, that was the Battle of the Bastards. But and it also gives you the count, 42 characters, and then does a really good job of saying, well, I don't want to list Stark soldier 41 times. I'm going to make that into a nice English sentence, including Rickon Stark, which is one of the major characters that you'd want to call out specifically. And then, of course, 41 Stark soldiers, they're sort of, the unknown soldiers. So we can see there that it does a really good job of returning the answer for that. And then finally, again, these are queries that so far I'm only leveraging nodes, relationships, and node properties. And in a second, we'll get to ones that leverage the property on a relationship, and that's the method property on the kill relationship. Before we get there, though, I want to show this particular query. So here, I'm asking who are victims in the episode. So I didn't say who died, right? I'm not even giving a form of the sort of conjugation of the verbs to die. I'm saying victims. And so the LLM knows enough to translate that into that it is leveraging, the death relationship, and then comes up with these, and again does a really nice job of a nice English language response where they give some specific individuals. They're sort of the more major characters in the series, and then it also says there were numerous others unsullied and such. So really nice response that gives you the specifics that you'd want to see, but also lets you know that there are a bunch of others that were sort of more generalized. Okay, so in that one, you'll note that I knew the episode was called The Long Night. But what if I do something like this, where I say who died in the Red Wedding? If you've watched Game of Thrones, you know this is a particularly sort of brutal episode where there's a wedding and unfortunately lots of people die. But what you'll notice is when I run this query, it should fail actually. And the reason is there is no episode called The Red Wedding. The episode that everyone thinks about this episode as The Red Wedding, but the episode is actually called The Reigns of Castamere. So here's a good example of a user's going to ask this question. They're not going to know the episode's Reigns of Castamere. They're going to know it as Red Wedding. And so it's going to say, well, I don't actually have any information to answer that question. But Red Wedding is, if you ask people about Game of Thrones, that's going to be in the top 10 of, interesting things that happened during the series. So, how can we fix something like this? And so what I'm going to do now is to show, this is the first example we've come to where we can start to use what's called few shot examples in the prompt templates to help the LLM better understand how to answer questions like this. So let's go back up here to this prompt template in the cipher generation template. And what I'm going to do is put directly in here a statement that if the user asks about the Red Wedding, know that that's the episode called The Reigns of Castamere. And so few shots like this, I wouldn't say are totally scalable, right? Because you don't want to have to put thousands of these things within here. Again, you're limited by your token length here. But for something like Red Wedding, I think it's important. Like, you want to get this one right. If you are making a solution over a database like this, there are going to be queries you know are going to be asked, and you want them to be right. And this is one way of making sure that when the user asks about this particular thing, the LLM will actually know how to answer it better. And so let's try that again. And as you can see, it now goes, oh, Red Wedding. I was told that that's actually an episode called Rays of Castamere. And so now it actually returns all the ones that did die in that Reigns of Castamere. And again, does a good job of, numerous Yunkai soldiers, like making this distinction between, here's a list of generalized things, and here are specific characters like Robb Stark, for example. So that's our first example of how you can use a few shot example directly within the prompt template here to inform the LLM even more. Now we're informing it a lot with this, right? By giving it the schema, so it knows, what these relationships are and what the nodes are. But you can start to get even more specific by giving more directions. And again, like I said, it's not 100% scalable because you are limited by token length. If you had many of these, which you may have in a full solution, then you'd want to go to something called fine tuning, which is a mechanism where you can take a whole bunch of these question and answer pairs and fine tune the database directly by giving it and having it update its weights based on a set of hundreds or even thousands of query answer pairs. And that might be ultimately the way to do this for a totally generalizable solution. But I wanted to show here that, even putting it within the prompt template becomes a fairly simple fix. Okay, so those are all the ones that just leverage nodes and the properties along with relationships. Now let's look at some queries where if you go back here, let's see, which one is it? The guild relationship here actually has a property on it called method. And so to date, we haven't used that yet in any of the queries. And so let's start to look at some queries that do use that. So, which character was killed by a shadow demon? A fairly simple query once you understand the schema and you know that there's this method property on the killed relationship. And again, you get a nice English language response. So let's try this one. And this will show you again, we'll do a few shot example on this one. The method property on the killed relationship doesn't really have anything about hanging. It only has what is equivalent some values in the database where that method property is noose. And so the LLM, isn't all knowing and all seeing omniscient. It wasn't able here to be able to say, oh, the person asked about hanging. I can change that to noose so it matches the values in the database. And again, it's one thing to keep in your mind here is we've told the LLM quite a bit about the schema of the database. We've told it nothing about the values in the database. And so it has no idea, really up until the time that it does this query and gets nothing back, that there's nothing that has the method equal to hanging on that killed relationship. But again, let's see if we can fix that with modifying the prompt. And so what I'm going to do here is, again, not completely scalable, but I can say, hey, if someone asks about hanging, that's really equal to a method of equal to noose, because I, as a database developer, know that noose is really how I've specified that as the property value. So it couldn't figure that out on its own, but we can give hints to it in terms of synonyms that take how a user might ask the question and translate that into the set of values that are actually in the database. So let's ask that again. Maybe I didn't save it. 1 second. One of the things is LLMs are a little unpredictable. And so that actually worked yesterday, but doesn't work today. So the one of the things you'll see as you work with LLMs, is actually a good thing to have come out, is even though I have temperature equal to 0 here in the creation of the OpenAI instance, you can ask the same question multiple times and get different answers. Now, in general, I would say more times than not, it's going to give the same answer with temperature equals 0, but not always. And as you can see in that particular example. So let's continue on here, and we'll say, how was Jon Snow killed? Again, this will be using that method property. And here what you'll see is, even though we've given the LLM a very clear definition of the schema, it incorrectly creates or creates an incorrect cipher where it's trying to think that the method property is on death, not on killed. See? And so this is the reason why it's returning nothing. And so, again, we can attempt to fix this by saying in the prompt template, reinforcing that method property is only available for the killed relationship. It's not a method property on the other nodes. And you could say, like, hey, didn't we already tell them that in the schema? And the answer is yes. But one thing you can also find in dealing with LLMs is that you can sort of reinforce things with them. And so, and how it takes directions, sometimes it doesn't hurt to overemphasize something. And so in this case, we're just sort of overemphasizing that method property is on the killed relationship, not on the death node. And once again, it's not giving the right answer. You can see it's giving 2 different answers there. If I go up, I ask the same question twice and get 2 different answers. This is where I think ultimately trying to do this within a few shots in the prompt is not going to ultimately be scalable enough. This is one where you're going to want to probably, in a full solution, go to fine tuning, where you'd have 100 of these that you would sort of offline in a CSV have them, and then LLMs like OpenAI have a capability where you can take that and then fine tune the database with those question and answers. And then with those questions and answers, it'll update its internal weights, and you won't have to use up valuable token space for trying to instruct the LLM further than what we would have done specifically just with having the schema. So unfortunately, those were two in a row that it still did not fix, even though it did last night. And so let's go to this next query. And this next query is one where this is obviously how a user would ask this question. But in the database, all of these methods on the killed relationship are capitalized. And so if we ask this question like this, what you're going to see is it'll say where method equals poison, and it'll return nothing because it's case sensitive in terms of this where statement. And so again, how a user asks a question dramatically different than how you as a Cypher developer would know the format of the values in the database, and would account for that with some sort of regex expression or to lower or whatever that would account for translating how a user would ask for this question versus what's the values in the database. So let's try this. That's you. Okay, so what you're seeing here is because I put in that example, it knew enough to then go, oh, I want to make this case insensitive. So really, it just does a to lower on the value to match anything capitalization that the user might have put in, and then gives a nice response back in terms of who was killed, again with generalized ones as well as specific characters. This is also one where different databases have different implementations. Another graph database may use the question mark period to do the case sensitivity for in a regex expression here. But the method that's most easily done here with Memgraph is the to lower. And so this is another one where it's kind of doing twofold double duty. One is it's saying, oh, translate this case sensitivity in terms of how a user might ask it. But you're also telling the LLM, here's the mechanism that's best used for the particular graph database you're using. In this case with Memgraph, the to lower works well. And so let's see, let's go back up here. So I'm going to try one of these again, just because I'm a masochist. Okay, so you can see here now, the few shot that I gave, it does actually say, oh, the person asked about hanging, but I was told if I'm asked about someone being hanged, that's actually the method of noose. And so it actually does return the correct answer here, primarily because, again, we gave this few shot example up here in the prompt that, hey, if someone asks about hanging, that's this noose thing. Now, let's just go down and try the other one that didn't work. Just so you can see. I believe it was this one. Yeah, so that one, still no love. But I was able to use this mechanism previously to where, it was able to figure out, well, that's actually, I think that is the right cipher query though, isn't it? In this case, it's just not doing a good job of taking the context and translating that into the right natural language output, which was actually doing yesterday. So, okay, so that's all of the queries that I wanted to show, and to show how you can leverage these extra text that you can put within the query to the LLM to give it extra directions. Obviously, the big one is obviously telling it the schema of the database itself. Okay, let's go back here. So what are some of the lessons learned along the way? The schema definition matters. The schema that is used in LangChain today for other graph databases just honestly doesn't work as well as the one we've come up with Memgraph. And so it's probably also true that even more experimentation might come up with even better schema definitions that help the LLM understand better. But I feel like we've made a pretty good improvement on the current state of the art to come up with a schema definition that works better. If you're doing this on your own, I found that GPT-4 is really significantly better than 3.5 for cipher query generation. 3.5, when I was using it, was actually kind of horrible. It was sort of hit or miss, 50-50. And when I switched to GPT-4, it got really, really significantly better. I don't have an answer for that or how it is on Bard or other LLMs, but I do know in my work with OpenAI that just go right to 4. We saw in some of the examples that the LLM knows about the schema, but not about the values. Whether that's a case sensitivity or something else. You as a graph database designer and developer have intimate knowledge of the cipher query that will be the right one to create the right answer. The LLM doesn't; it just knows about schema, and so you're either going to have to use few shot examples like I've shown, or fine tuning to help account for that. How a user asks a question is not necessarily how a cipher user would ask a question. So a good example here, and I didn't have a query on this one specifically, I don't think. But if you say, let's say you say which character was killed by a sword, what it's going to do is give you the top one of that. And when a user asks a question like that, it's pretty reasonable to assume that it would want to know all of the characters, even though it asks it as a singular statement. Like if you asked which character was killed by a sword, I think an expectation would be, hey, this solution be smart enough to just show me all the people that were killed by a sword. And the cipher query generated is going to give you a top one in that specific case, and only give you whatever it happens to return as the top one. And it leaves information out for the user, right? The user doesn't know that there's 19 other people killed by a sword. It only knows the one that got returned. And so again, you can use few shot examples or fine tuning to help with this. That's easier than a different part of the solution where you may say, oh, well, ask it several ways. I might translate that natural language in several ways. Ask the LLM a bunch of questions and then give one that has maybe the most response or the more interesting response. But if you're doing this sort of one question, one answer kind of response like I've shown today, you'll need to do that through few shot examples or fine tuning. I showed the case sensitivity example like with the method on the kill relationship, like with poison. And again, you saw how a simple little clue to the LLM to make that case sensitive or case insensitive came up with the right answer. And as you can see, working prototype where we're trying queries like this on a smaller database is one thing, but a full end user solution is another. We didn't really show any UI in this implementation. And so I think it's pretty impressive what an LLM can do. I would not have thought it could do maybe even half of those queries going into it. So I've been pleasantly surprised at just how functional it is. But there are always going to be these edge cases and solution specific things where you're going to want to be able to use things like the few shot examples to make the solution better for the end user. So what are the next steps? Well, you saw in the code that I was leveraging this LLM util schema function. And you may know of the meta util schema function that's available today as a MH query. One thing I've worked with Memgraph on is creating this new function that creates a prompt ready format. And really that is that text that you saw. That would be just to make so you remember this format of the schema, right? That can now be outputted directly using this function, and that makes it really easy. So anybody who wants to, automatically take, hey, that's a great schema definition, I'm just going to inject that within the prompt directly in my solution. You can do that directly by just calling this function. And then they've also created a raw format that is comes out, if you know meta util schema, comes out in a set of dictionaries. You can also ask for the raw format and then format it as you see fit, because maybe you've come up with a better definition of schema, and you can do that as a developer. And then obviously the next step after the releasing this new function is to then take the Memgraph class that I've created and do a PR into the LangChain framework. So this is available for everyone. I'm pretty confident we can get that done, given that, as you've seen, that class that I created is actually quite simple at this point, particularly now with this function. I would say 80% of the code before was just parsing meta util schema into the format I wanted. And so getting rid of that and just calling this one function made it super, super simple. And so next step would be to just get LangChain to PR that back into the framework for everyone to use. And then with that, I think we're at Q&A time. So anybody have any questions?
So if someone has questions, you can unmute yourself. And if no one asks, we have a couple of questions in the chat, so I can read them out loud. So if you want, you can ask. Okay, so I'm going to read one question from the chat. So if you asked, before you asked something like related to that, so what if you ask who was the most violent character? Would it have like a language connection that connects deaths with violence? Or would you need to provide it also like you did?
Well, we could try it, but I don't think it would work. I don't think the LLM is going to be able to translate that into character who killed the most. I think that is something that you'd have to sort of nudge the LLM into, just like we nudged it with the hanging and noose being equivalent. I do think if you put that into the prompt template, you would be able to get an answer for that. And again, not completely scalable, right? You're not going to do this for every kind of version of this. But if you thought in your solution, that was a question that was going to get asked a lot. Just like I thought, Red Wedding, that's like a seminal moment, right, in Game of Thrones. People are going to ask about it. You'd want to account for that. And so I would say, I don't think it would do it without any specific nudging in the prompt template. but I do think it would fix it with the right addition to the prompt template.
Okay, and a lot of people are mentioning here pricing. So someone asked, using LangChain with the OpenAI GPT-4 model can be expensive, and I think that as the schema is included too. I'm curious how open source LLMs like Falcon might perform in comparison. Do you maybe know like a comparison of the pricing, or at least comment on the pricing of OpenAI LLM?
Yeah, well, first of all, I'll say personally, I don't think the OpenAI is that expensive. I did a different project where I was creating thousands upon thousands of KPI examples, right? I was like, hey, what are great KPIs in the cement industry that a CEO would want to see on a daily basis? Just get like thousands of these things, and I think at the end of the day, I paid $1.86 for all of that project for thousands of. So I don't think it's hugely expensive in that respect. But if you do want to use an open source implementation, LangChain does support a whole bunch of different implementations of LLMs, both proprietary and open source. And so LangChain could still be a good framework to leverage for it. I personally have not tested any of the open source LLMs to see how they function along with it. I'm a little skeptical just because of the difference I saw between 3.5 and 4 in GPT, where 3.5, I would say, really wasn't, I wouldn't use it for a solution. But 4, I would. And so, the open source models are catching up quite quickly, right? They're doing amazing work to making me smaller, faster, cheaper. And so I can see that happening certainly eventually and probably soon. But my gut feel is because of this 3.5 to 4 difference that I saw, they may not be as good. But it all depends on how much they were trained on, specific examples for Cypher queries, right?
And you were mentioning scaling a lot. Since you are like in LLMs a lot now and AI rabbit hole, do you have like any idea where that might go? Do you have like any idea what's the progress regarding scaling on LLMs?
Yeah, well, we've already seen them scale quite amazingly in the last 9 months or so, right? And so again, GPT-4 is just sort of another step change in what it has been able to do. So that's one type of scaling. The other type of scaling is, GPT, OpenAI, they announced the 32K tokens. I don't think it's available yet because they're constrained by the number of GPUs they can get. So I think it's maybe still constrained down to 8K tokens. But 8K is still a whole lot more than what you're getting today. And so in terms of, the examples I've shown for inject them into the prompt template, 32K is pretty big, right? Like that's like you'd be able to, inject in whole PDFs directly into the prompt template without doing, sort of the more complicated path you got to do now of, taking that PDF, tokenizing it, getting into a vector database, doing some sort of retrieval on it, and then taking the top K and injecting those in the prompt template because you only want the top K there to limit the number of tokens you're putting into that prompt. And so I think the increase from to 8 and then to 32K for the number of tokens will probably be the most noticeable scaling factor people see in the short term.
Thanks. Does anyone else have any question? You can. Okay, there is another question at chat. So would it be possible to train LLMs as a human language UI to Memgraph, which will generate Cypher underneath, so it will be totally transparent for the business users and not require for them Cypher knowledge?
Yeah, I think we've shown that you can do that today. I was only showing the Cypher implementation so you could see what it was doing. If I put verbose equals false in the Cypher QA chain that I created, the only answer you would get is that final English answer. And so that then looks a lot more like what you're asking there, which is someone just asks a human language question, like, who killed Jon Snow? And then what would come back is just that English language response. I was only showing the intermediate steps so you get a sense of what's happening under the covers. But I would also say, I've also shown that like there are going to be edge cases where it's not going to be good at it. And so you're going to, you'll have a fair bit of testing, you'll have a fair bit of what are the things that people are going to really ask for? And really understanding, and I'll come back to the red wedding thing again, people are going to ask about that. And if your solution doesn't know how to respond to that, it's going to be seen as an inferior solution. And so while the generalized solution does a pretty good job of all these queries, you could see there's a certain set of them without some few shot example or some other nudging to tell it what to do, it's going to get the answer wrong. And so that's going to be, you always say like, the last 20% of a project is 80% of the work. That's the last 20% for any solution you'd want to do that is, as you're describing, is you'd get 80% pretty quickly, like very quickly. You saw like in like 4 lines of code, you could, get the basics of this working. But the 20% that's going to be difficult is, oh, what are these sort of edge cases where the cipher is not generated quite correctly, and I've got to use a few shots or fine tuning to account for that.
Yeah, so it is possible, but like we cannot still verify if the results are always going to be generated or correct still. But I think like from the graph database point of view, maybe like it's a good thing if data doesn't change that often. So if you just have like a static data set that is not that large, and maybe if you know the data set to heart, and the questions that your business users are always asking, if those are the repeating questions, then this is a probably easier task. And I think that idea is great because people are stumbling upon issues with learning cipher if they don't know it. So it's a great idea, but yeah, we'll see where this goes. Yeah, the case for retraining the LLM, like said in chat, yeah.
Yeah, and again, you do have the option of fine tuning even with a proprietary model like OpenAI. So, retraining, you're not, spending the hundreds of millions of dollars to retrain the entire LLM. You're doing the fine tuning examples to help, adjust weights. And so that's a fine example of getting better at it. If you have an open source model, maybe the correct answer actually is to do a full retraining. But it depends on what LLM you want to leverage.
Mm-hmm. Great. Yeah. So does anyone have any other question? Those were great questions in the chat, but if you want, you can turn on your mic and ask anything you like. Otherwise, Brett, this was an awesome talk. I really enjoyed it. Yeah, with live demos, it's always like that. I wrote it in the chat, like always something goes wrong, but it's not your fault, it's LLM, so don't worry. But the presentation was still awesome. And I think everyone else also liked it. There were great comments in the chat. I'm not sure whether you're seeing it, but everyone were excited to see the results that you obtained. Yeah,
and
so
I would also say, I am on the Discord channel, so if you have any questions or follow-ups, I'll monitor it and we'd be happy to answer any questions you have or work through a solution with you if you want.
Amazing. Yeah, I'll send a message like a reminder to this call, and I'll tag Brad so that you know which is his handle, and feel free to contact him like you said. Then I guess this is it. We'll wrap it up. Thank you all for joining us, and hope to see you all on the next Memgraph community call. Thank you, Brett, for holding the presentation, and hope to see you all very soon.